This is our setup for the series LCR experimental kit. We can use it to find the resonance frequency from the frequency response curve. This comes with a detailed manual which consists of the procedure and the experimental data and the graph for doing the experiment. And this is a self-sufficient kit. It has a audio oscillator having frequency up to 10 kilohertz. It has a resistance bank on the left hand side, and also a two terminals are given for attaching any resistance of your choice. It has got an inductance bank consisting of 3 inductances, 40 millihenry, 60 millihenry and 80 millihenry, and it has a capacitance bank consists of 4 capacitance, and also 2 terminals are given for attaching any capacitance of your choice. It has got 3 meters. On the left hand side is a voltmeter, and in the middle is a milliamp meter, and on the right hand side it's a digital frequency counter. On the right hand side over here we have the amplitude control with this knob given over here, and the amplitude can be also set with this selector key, 1 volt 10 volt selector key. We will now move on to the circuit connection for the series LCR circuit. This is the series circuit connection as given in the manual. The detailed circuit connection is given here. Now we'll move on to the circuit connection. So we are first connecting the output of the audio oscillator to the circuit on board. Next we are connecting the resistance. And then the milliamp meter in series with the resistance. And then the inductance in series with the milliamp meter. And the capacitance in series with the inductor. This completes our circuit. So finally we connect the voltmeter. The voltmeter will be connected first across the input terminals over here. For that we are using the stackable jacks over here. There are 2 stackable jacks which will be provided, and now you will connect the voltmeter. The stackable jacks are used for connecting the voltmeter across the resistance if you want to measure the voltage across resistance. Right now we are measuring the input voltages, so the voltmeter is connected across the input terminals. We will now switch on the circuit and we'll take down the readings. So we have made the circuit connection. So we have connected the resistance, this resistance 220 ohms. We have connected the inductance 60 millihenry, and we have connected the capacitance 0.47 microfarad. Now we'll switch on the circuit. We'll set the input amplitude at 2.5 volt as shown here in this voltmeter. So set at 2.5 volt. Now we will set the frequency. We will press there are 3 types of selector switches over here: 10 Hz, 100 Hz and 1 kHz range. So we will just press 1 kHz range and make sure that this frequency knob is at the minimum position. Now we'll change this frequency and look at the reading in the frequency counter, and also we can note the current over here. Now if we want to measure the voltage across the resistance in this voltmeter, we will simply take out the connections from the input and we will put it across R. For now we are noting the input voltage only. In the next one we will note the voltage across the resistance. So we'll change the frequency. The frequency is increasing, the current is also increasing. The current has started to decrease. So we will note the maximum value of the current. Current is still increasing. It started to decrease, so we'll just go back. This is the maximum current that we are getting. It corresponds to 820 Hertz. Now we will have a look at the table over here. A lot of combinations are given. You can check it for any combination. The resonant frequency comes to around 820 Hertz for a combination of 220 ohms resistance, 60 millihenry inductance and 0.47 microfarad capacitance. Theoretically, if we calculate it, it comes to around 1100 Hertz. So we have got a very near value. We will now do the experiment for another combination. Notice the input voltage over here. We had set it at 2.5. It has increased very less. It has become now 2.77. If you want, you can also change this using this amplitude knob, or you can just leave it because this is a very minimal increase. So we will have a look at this for another combination. We have now connected this 560 ohm resistance, this 40 millihenry inductance and 0.22 microfarad in series. We have connected the voltmeter across this resistance. See, this is the one point of the resistance, so we have connected it over here, and another point of the voltmeter is connected to the stackable jack on the other terminal of the resistance. So now we will change the frequency and we can also note the voltage VR over here and also the current. As we change the frequency, both of them are increasing. It starts to decrease. So we have to go back to get the maximum value of both the voltage and the current. So this is the maximum value we are getting. It is 1597, 1.5 kilohertz, 1.6 kilohertz almost. And if we calculate the value by theoretical calculations, it comes to around 1450 kilohertz. So we have got a value which is very near to the resonant frequency. It's obtained by theoretical calculations. All the tables are given over here. These are the formulas. This is the formula to find the Q factor, where F0 is the resonant frequency. These are the tables. And this is the resonant curve which will be obtained. So this concludes our experiment for the series LCR circuit. Thank you.
Please subscribe to our channel for more such videos. Thank you for watching.